So let's move forward to the compound interest calculations. From compound interest calculations, it is actually almost universally compounded to include interest on interest. So we are rarely going to find a simple interest calculations in our industry. As a matter of fact, in most of the industries, they use also compound interest, which is you having interest on an interest, as I just mentioned. So let's do the same example before, but we do the calculations of having compound interest calculations and not simple interest calculations. And let's remember here, we did the borrowed around $1,000 and the interest was 10%. So let's say an I equal 10%, just as a reminder. And we have the principal of the amount borrowed was $1,000. So let's draw a table here similar to what we did before. And we said the first column, we have the year. And the second column, we have what we call the base, where we will apply the interest in every year to study it. And the third one, we said that we want to calculate the interest. And we have at the end the future value, or the total amount owed towards the end of every year. And we said the first row would be now, the second row would be year 1, the third one will be year 2, and let's say 3 years, similar to what we did of the simple interest calculations. And we said the principal is $1,000, and the $1,000 then for now, which will be the amount borrowed. For the first year, when we apply the interest, the 10% on the $1,000, so the base will be also $1,000, and the interest will be the 1,000 times the 10%, which will give you the $100. So the total amount owed at the end of the first year would be the $1,000 plus the $100, which will be actually the same as, this is, let's say, F1. Same as the simple interest calculations for the first year. Now, where is becoming different? It will be in the second year and moving forward. The second year, the base to apply the interest would be then the total amount at the end of the previous year, which in this case, the $1,100 F1. Let's actually, so as it's gonna be better understanding, here that will be F1. So F1 here would be the base for year number 2, $1,100, and the $1,100 you will apply the interest, which is the 10% on it, which this case will give you the $110. And here, what's happening, what we did is we took the base for year 2 is the total amount owed at the end of the previous year, which is $1,100 F1. So that will be F1. and the F1 times the 10% to calculate the interest for year number 2. The interest for year number 2 will be $110 because you multiply 1,100 times 10%. And the $110, you want to calculate what is the total amount owed towards the end of the second year, will be the 110 plus the F1, which is the 1,100. 1,100 plus 110 will give you $1,210 for the end of year 2. That's the amount owed. So from learning what we did in year number 2, the base for year number 3 would be the total amount owed in the previous year, which is F2. So as you can say, you are actually paying interest on interests. So in year number 2, you included the amount of interest, which is the $100 from the previous year, and you multiplied by the 10%. So you put the 10% on the principal, the $1,000, and you put the 10% on the interest from year number 1, which is the $100. For year number 3, then you have a base of $1,210, and the $1,210 here you multiply by the interest. So that will give you $121. So what we did, the interest of year 3 will be the 10% times the total amount towards the end of the previous year, which is year number 2, which is 1,210. 1,210 times the 10% in the question we have, it will give you $121 interest in year number 3. The interest in year number 3, you added to the total amount on the previous year, which is $1,210, plus the 121, it will give you $1,331, the total amount owed at the end of the third year, and then you can continue with the same as many years as you want. So what we did here that is different than the previous simple interest calculations was applying the interest on the interests from the previous year. So you always include the interest from the previous year and you keep adding up to it. And we can take in a minute an example to see what's the differences in the results here. So let's move forward and look at the equations now. So based on what we just explained on the table of how we did the compound interest calculations, let's drive here the equations. The F1, which is the future value of the total amount owed towards the end of the first year, would be that present or the principal that you borrowed plus that same amount times I, the interest that you have, which will be P equal 1 plus I between parentheses. If you remember what we did, we applied interest on interest. So in this case for F2, we have F2 equal to F1 from the previous year plus F1 times I, because we have interest on the interest. And F1, you have the principal, include in it the interest from the first year. So in this case, F2 would be equal to F1 times 1 plus I, similar approach what we are doing from the first bullet point. And if we want to substitute F1 with the equation from the first bullet, we have P times 1 plus I to the power of 2, because you have 1 plus I times 1 plus I. Also, F3 the same. You have F2 times 1 plus I, and F2 equal P times 1 plus I to the power of 2. If we take this and have it here instead of F2, so we have 1 plus I 3 times. So we have P times 1 plus I to the power of 3. So if we have n number of years, then the future or the total value owed at the n number of years or n number of periods of times, we have the principal you borrowed, the money or the present value, times 1 plus I to the power of that n number of periods. So from here, what I want you to remember and take from the compound interest calculations, which that will be our focus for the course. In matter of fact, I highly believe this is what you will be experienced in your career. I would like to summarize these two equations. The first one, which is, we call it the future value. The future value of any value you borrowed or loaned at n number of years will be equal to the P, that amount, which P here we refer to as a present value, times the 1 plus I, the interest, to the power of n. So the interest that you have in the question to the power of the n number of years that you want to highlight what is the future value of that in n number of period of times. So if you want to reverse it, let's say I want to put in the bank or to have in the bank in 3 or 4 or 5 years from now around $10,000. How much in the present I want to put in the bank if I have an interest rate equal to I%, 2, 3, 4, 5%. So from this equation, from the first equation, you just like flip the two sides. So it will be then the present value equal to the future value that you want to find at the end, divided by 1 plus I to the power of n. So it's either or, it's the same equation, but this is we refer to as the future value equation, and this is the present value. And this is the basic first block in the time value and the mathematics of money topic that we are explaining in this course today. So let's move forward.